gotta talk to you.
Can I help you, sir?
No, it's alright. I know this guy. He's a professional. We really have to help him out.
Actually.
I'm a detective. I work for the FBI. I need your help in a murder investigation.
We better help this guy out. Let's go.
The shooter took a shot from that window up there.
I'd say this is a good 15 feet high.
Where was the body located?
I'll show you. Found the body right here.
That looks pretty far.
We measured it to be 50 feet away from the wall.
Detective, do you have the gun the suspect used to make the shot?
Indeed we do.
Interesting. I'll need to run some tests to make sure of the range and accuracy of this gun, and then we'll get back to you with an answer.
Do you really think the bullet can make it that far?
We'll have to go back inside and do some more calculations, but I think it might.
What are we waiting around here for?
There we go. I have an idea of what we're going to do. Now, it's going to require a complex bit of math work, but I think we can pull it off.
I'm allergic to math.
It's okay. We'll get it done. So, here is our shooter. Here is his gun. Now, assume he's holding the gun 5 feet off the ground. And then he shoots the bullet. It's going to fall in a parabolic arc to the ground. Now, I've already run some tests with this particular type of gun, and I've determined that the average distance it falls is 30 feet. That means the gun will travel 30 feet through the air before the force of gravity pulls it down to the ground. We can overlay this diagram onto a coordinate grid. The muzzle of the gun will be at the point 0, 5, and the place where the bullet hits the ground will be at the point 30, 0. Our parabola will look something like this. Now, the standard form for an equation of a parabola like this is y equals a times the quantity x minus h all squared plus k. Now, the vertex of the parabola is at the point hk. Our vertex happens to be at the point 0, 5. We can plug these values into our equation by now saying that y equals a times the quantity x minus 0, our h, all squared, plus 5, our k. In order to solve for a, we're going to need a y value and an x value, which we can get from our parabola. We can use the point where the bullet hits the ground at 30, 0 to plug in using 30 as our x value. Now the equation looks something like this. 0 equals a times 30 minus 0, quantity squared, plus 5. Now we can solve for a. Alright, this segment here can be simplified by saying 0 equals a times the quantity of 900 plus 5. Or, you can write that a different way, 0 equals 900a plus 5. The 30 minus 0 is just 30, and the 30 squared is 900. So 900a plus 5 equals 0.
Go.
We subtract 5 from both sides of the equation to get negative 5 equals 900a. We divide both sides by 900 and get that A equals -1 over 180. Now that we have our A value, we have our equation. Y equals -1 over 180 times the quantity x minus 0 all squared plus 5. This is the equation for our parabola.
But sir, that is if the person is shooting from the ground. We need it from the guy shooting 15 feet in the air.
That's okay. All we have to do is shift our parabola up 10 feet to get the vertex at 0, 15. This means our new parabola will have the shooter at 15 feet instead of 5. It'll still make a parabola, but because it's farther up, it means the bullet will go farther. We need to calculate that now. If we translate this parabola back into the equation, down here, all we need to do is change this 5 to a 15. That accounts for the vertex being moved up to 0, 15 instead of 0, 5. So the new equation is y equals -1 over 180 times the quantity x minus 0 all squared plus 15 now instead of 5. It's the same equation except that this is a 15 and not a 5.
This guy really seems like he knows what he's doing.
Yeah, I really don't like the math.
Neither do I, but we need to do this to solve this case.
Action.
Come on guys, we need to focus here. Now we determined that the victim was shot 50 feet away from the window. That means that this person shot a bullet. If it lands closer than 50 feet, that means it couldn't have reached him and he's innocent. If it was farther than 50 feet, that means the gun was capable of making the shot and the victim is dead and the suspect is guilty.
So how do we find where the bullet landed?
All we need to do is find out where our new parabola from our new equation intersects the x-axis, in this case represents the ground. So we need to calculate the x-intercept by using our equation up here. Now you remember that the x-intercept is calculated when y is 0. Plug in 0 for y, we get 0 equals -1 over 180 times x minus 0 squared plus 15. Now this x minus 0 bit will simplify to just x squared plus 15. Now we subtract 15 from both sides to get -15 equals -1 over 180 x squared. Now we have to divide both sides by -1 1/80th. Now, because it's a triple fraction, it'll just be a regular number, and the two negatives will make it positive. When you punch this in on your calculator, it equals 2700. Because it's x squared, we have to take the square root of both sides. Square root of 2700 is around 52, and that would equal x. So, this 52 means that if a person shot that particular gun from 15 feet in the air, its maximum shooting distance would be 52 feet. So the bullet will hit the ground at the point 52, 0. Our victim was found here, 50 feet away from the target, at the point 50, 0. That means that the gun had enough power to make it to the victim, which means that our suspect is guilty.
Action.
So that means he is guilty.
Good.
That's right. I'm glad we could be of service.
Action.
Well, let's go get him. Let's go.
Medic!